Everyone. Today we are going to write MATLAB code for Lagrange interpolation method. So before that we will discuss its analytical approach to solve particular example with the help of Lagrange interpolation. Then after that we will discuss its flowchart and how to write code and its execution. So guys, here problem is given. Okay, we need to find the value of function using this Lagrangian interpolation formula. Okay, and we have the set of data points given, x reading and y reading. So here total 4 readings are given, and for corresponding x reading we have the value of function in terms of y, and here we need to find the value of function when x is equal to 3 by using this Lagrange interpolation. So first thing, you need to write all the set of data points. So we have the 4 readings, so just write it. Okay, so we have x0 value, x1, x2, x3. Same way we have corresponding reading for y0, y1, y2, y3. Okay. Then to find the value of function using the Lagrangian method, okay, we have the relation. We can say that we have the relation value of the function is equal to L0 into Y0 plus L1 into Y1 plus L2 into Y2 plus L3 into Y3. Okay, so when you are putting the value of L0, L1, L2, L3, Y0, Y1, Y2 in this formula, you will get the value of the function. Okay, so here what is Y0, Y1, Y2, Y3? So here Y0, Y1, Y2, Y3 are nothing but our set of data points, okay, which are already given here. Now let's find what is this L0, okay, L0, L1. So these are the Lagrangian coefficients. So for that we have the equation, okay. So L0 we can take the xg minus, okay, so x0 means here for first reading we are finding the Lagrangian coefficient, so we can write here xg minus x1, okay, then xg minus x2, then xg minus x3, okay, and it will be now divided by our x0 minus x1, x0 minus x2, and x0 minus x3. Okay, so we have the values of x1, x2, x3. Okay, and in this case, xg is nothing but the value of x. Okay, at which we need to find the function. Okay, in short, we need to find the value of y. So xg is equal to 3 in that case. So here, just substitute the value of x1, x2, x3, okay, in this. So you will get the equation for L0. Same way, find Lagrangian coefficient L1. So L1 you can write xg minus x0, okay, xg minus x2, xg minus x3, and it is now divided by x1 minus x0, x1 minus x2, and x1 minus x3. So just substitute the values of x0, x2, x3 in this equation. So you will get the function L1 coefficient. Same way you can find the L2. So L2 is equal to xg minus x0, xg minus x1, xg minus x3. It is now divided by x2 minus x0, x2 minus x1, and x2 minus x3. So just substitute value of x0, x1, x3 in this equation. You will get the equation in terms of L2. Okay, so on you can find the value of L3. Now once you get the value of L0, L1, L2, L3, okay, so just substitute those equations, okay, in this relation. So L0 is equal to, so this is the relation, what is the value of y0 at that time? 2. Same way L1, write that equation, then value of y1 is 3, then L2 y2, okay, then L3 y3. So in this case, value of xg is given as a 3. So just substitute the value of xg 3 in this equation. Okay, and just simplify this equation. You will get the answer. Okay, and the value of function y at x is equal to 3 is a 35. So this is the analytical approach for Lagrangian interpolation method. Okay, now we are going to write the flow chart for this analytical procedure. Okay, so let's discuss the flow chart. So here flow chart, okay, you just start your code, okay, then whatever the input required. So in the particular problem statement, just we require we need to enter the set of data points. Okay, so here total set of data points are 4, so we are going to enter those value. Okay, so read n, so here n represents the set of data points. number of data points. Then also we are going to enter the value of x, okay, at which we need to find the value of this function. So we will enter this xg is equal to 3. So here you can enter the value of xg. Now we need to enter all those value x0, x1, x2, x3 simultaneously, y0, y1, y2, y3. Okay, so we are we can help take the help of here looping. Okay, so here you can use for loop. So I'm here defining the for I is equal to 1 s to n. Okay, so we need to enter the values of x and y. Okay, so from first reading to the n number of readings. So here total 4 readings are there. So we can enter the value of x and y as x1, x0, y0, x1, y1, x2, y2, x3, y3. Okay, so the purpose of this loop is just to enter the reading, xy reading. Now we need to find the value of y, okay, when x is equal to 3. So let's assume the notation for that value of y is yg, okay. So initially we are taking this yg is equal to 0, okay. Now next step here we need to represent this equation, okay, Lagrangian equation, equation for coefficient. Okay, so suppose if you take L0 xg minus x1 xg minus x2 xg minus x3, okay, divided by x0 minus x1 x0 minus x2 x0 minus x3. So this equation we need to write in the form of code. So first we will identify the our numerator, then denominator. Okay, also we need to find the Lagrangian coefficient L0, L1, L2, L3. Okay, so for that here I am taking the loop. Okay, and here the loop, purpose of this loop is here for I is equal to 1 s to n. Okay, means the purpose of this loop, we are going to find the value of L0, L1, L2, L3, okay, up to the set of data points. So in this case, we have the set of data points, total points are 4. So we can find the value of Lagrangian coefficient from first reading to the fourth reading, L0, L1, L2, L3. So by using this loop, we are going to find the Lagrangian coefficient L0, L1, L2, L3. Now initially we will take the numerator is equal to 1 and denominator is equal to 1. Okay, so these are the base values of numerator and denominator. Now in this numerator and denominator we are going to provide our equation. So for that I'll take the one more loop. Okay, so I'm defining the loop inside this previous loop. Okay, and here I'm taking for j is equal to 1 s to n, and the purpose of this loop is to just develop this equation. Okay, so we need to write this equation xg minus x1 xg minus x2 and xg minus x3, and it is divided by x0 minus x1 0 minus x2. So to write this logic, we are going to take one more looping, and here we are providing one condition. Okay, what is that condition? If I is not equal to j, okay. So this symbol represent not equal to j. Okay, so when I is not equal to j means we can say that. So when our I is 1, okay, and that time j is equal to 1, so your I value should not matches with your j value. Okay, that time, okay, we are writing the numerator as n. Okay, so n is initially 1 into xg, okay, that we have defined in the input. Okay, minus xj. So what is the value of j? X1. So xg minus x1. So here we can write xg minus x1. So this is the first term, xg minus x1. Okay, now the loop will again in denominator we can write x. What is the value of I is 1. So x1 minus what is the value of j? 1. So x1 minus x1. So it becomes 0. So this condition should not be true, because if we are taking here x1 minus x1, so it becomes 0 and you will get the infinite solution. So to avoid this conflict, okay, so we have taken this condition I and j value should not be same. Okay, so in that case the loop will continue, because j is equal to 1 will not be considered in this case. Okay, so here just go for next j is equal to 2. So in this case xg minus x2, and in denominator you will get x0 minus x2. Okay, then in the next condition you will get xg minus x3 and x0 minus x3. Okay, so this is about your L0. Okay, once you get L0, so this I loop will be continue. I becomes 2 means you will get the L1 value. Okay, and for L1 same way you can take the loop j is equal to 1 s to n. Okay, so when I and in j are not equal. Okay, both are, we are defining the numerator. Okay, so in this case xg minus, what is the value of j here? Xg minus x1. Okay, then denominator, yes, in this case your denominator is the x1 minus here x0. Okay, see here x1 for L1, it is x1 minus x0. Okay, then in the next time it becomes xg minus x2, and here x1 minus x2, here xg minus x3, x1 minus x3. Okay, so the purpose of this looping is to define the numerator and denominator. Okay, and once this loop is completed from I is equal to 1 s2, and once you get the 4 reading L, so here you will get L0, L1, L2, L3. Okay, and by using this loop we are defining its relation. Okay, for the Lagrangian coefficient, and after the end of this loop, okay, so here you can write L0 Li. Okay, so L of I means here you will get L0, L1, L2, L3, and here we can take the ratio of this numerator and denominator. Okay, so here you have defined n and d, so take the ratio of this, and at the end just make the addition of this yg plus li into y of I. So initially yg we have considered as a 0. See here yg we have taken 0. So we will get 0 plus, yes, L of y into y of I. So for first iteration it becomes L1 and it becomes y1. So you will get L1 y1. For second iteration it becomes L2 y2. For third iteration it becomes L3 y3, so on. Okay, and at the end you will get the total sum of this yg, and that yg is your answer, and you can print this answer. Okay, so this is about flowchart. Now this flowchart we are going to write in the form of code. Okay, so this is the code. Okay, so here I'll show you. So first you can start with the CLC clear all. Then you can enter the number of reading. So here n is equal to number of reading. Now next thing, just look in the flowchart. What we have to do? We need to define the loop for input the value of x and y. Okay, so for that we can write this code. So for I is equal to 1 s to n, so when I is equal to 1 we are going to write the value of x1 y1, then I is equal to 2 x2 y2, then x3 y3, x4 y4, total 4 readings are there. Okay, then define the input value xg. Okay, so in your case xg is 3. Okay, in the particular problem, then initially assume the value of yg is equal to 0. Then define the looping. Okay, so here you can define the loop for j is equal to 1 s to n. Okay, that time we are taking numerator is equal to 1 and denominator is equal to 1. Okay, the purpose of this loop is to just find the value of Lagrangian coefficient. Okay, what is Lagrangian coefficient? L0, L1, L2, L3. Okay, so in the coding you will get L1, L2, L3, L4. Okay, because we are starting from 1s to n. Okay, and while doing analytical calculation we have considered the variable as a x0, y0, okay, x1, y1, okay, x2, y2. So in coding it will start with x1, x2, x3, x4, y1, y2, y3, y4. Okay, then purpose of this loop is to just write this equation. Okay, what is that equation? Yes, this equation. Okay, xg minus x1. So for L0 you will get this relation. For x1 you can write this relation. Okay, for L2 you can write the same equation. For L3 you will get this equation. Okay, and at the end you can make the uh, ratio of the numerator to denominator, so you will get the Lagrangian coefficient. Okay, L1, L2, L3, L4, and at the end just make the addition of yg. Okay, initially yg is 0. Okay, then make the multiplication of this Lagrangian coefficient into the your y reading. So L1 y1. For second case it becomes L2 y2. Then next, because this loop is continued here. Okay, so you will get L3 y3. Then you will get L4 y4. Okay, and this yg gives you total summation of L1 L2, L1 y1, L2 y2, L3 y3, L4 y4. Okay, and this addition you need to print, that is your final answer. So this is the code for Lagrangian interpolation function. Okay, so you can execute this code. So you have the number of options to execute this code. Okay, so whatever the code you have written in Notepad, or WordPad, so you can run it with the online Octave solver. Okay, so Here you will get the online Octave. So just in Google you need to type Octave online. Okay, you can type Octave online. Okay, so this is one of the online tool to execute the code. Okay, here you need to just do the login, and here you will find the plus symbol, so you can add the file. So here I am writing the name Lagrange Interpolation. Okay, so save this file. So here you will get this file. Okay, just click on this file, and whatever the code is there, so just paste it. Okay, so this is the code. You can paste it and save this code, and here you will find the run option. So click on the run button, so your output will be displayed here. Okay, now you need to just enter the value. So look at your problem statement. So in this particular problem, okay, so we need to enter the this value. Okay, so first thing here, it is asking me the number of reading. Okay, so we have taken n coefficient to the n variable to represent the number of readings. So total 4 readings are there. So just type 4 and enter. Now it is asking the x value. Okay, so what is the first value? First reading 0. So you can put x is equal to 0. Corresponding value of y. So what is the value of y? It is 2. So you can enter 2. Then next reading, x is equal to 1. Okay, what is the value of y? Y is equal to 3. So you can enter the y is equal to here 3. Okay, then next reading, x is equal to 2. Okay, what is the value of y? Y is equal to 12. Then x is equal to, next last reading is a 5, and y is 147. Okay, now it is asking the value of xg. So what is the value of xg? In this case we need to find the value of function when xg is equal to 3. Okay, so substitute xg is equal to 3. So xg is equal to 3. So here you will get the final answer, and final answer yg is equal to 35. So you can cross check this answer with your theoretical calculation. Okay, so for the same, so this yg is equal to 35. Okay, so this is your required answer. Both the answers are same, so you can say that. So this is the MATLAB code for Lagrangian interpolation method.